looking at textbook page 430, question number 5. Duncan dives with a junior swim team in a dive-off a 7.5 meter platform. He reaches a maximum height of 7.94 meters after 0.30 seconds. How long does it take for him to reach the water? Well, let's first sort of just sketch a function with time on the x-axis. So let me just pull up some tools here. So we have time on our x-axis and seconds. We know that he starts at 7.5. That's our height. And it's in meters. And after 0.3 of a second, 0.3 seconds, he hits 7.9. Right, this is a height of 7.94 meters. So we have this point, we have the maximum height, and what we are looking for is the 0. So we're going to start by creating an equation. And I'm going to write this equation in vertex form because I have the maximum height. And so y is equal to ax minus h squared plus k. My vertex is 0.3 seconds and 7.94 meters. So y is equal to a times x minus 0.3 squared plus 7.94. I need to use a second point to calculate a. Let's see if I can write that correctly. Second point. And our second point is going to be our y-intercept, 0 and 7.5. So y is 7.5 is equal to a. We have 0 minus 0.3 squared plus 7.94. So the first thing we're going to do is subtract 7.94 from both sides. And that leaves us with negative 0.44 is equal to a times negative 0.3 squared. Now, negative 0.3 squared is 0.09. So we have negative 0.44 equals 0.09a. We divide both sides by 0.09, and that gives us negative 4.89 is equal to a. Okay, so now we have our vertex. We should be able to, there we go. Or sorry, now that we have our equation, we need to find our zeros. Y is equal to negative 4.89 times x minus 0.3 squared plus 7.94. We could graph this and solve it. We could turn it into a quadratic equation in standard form, solve it, but that is how you put it into an equation. So I've just managed to open up my calculator. Of course, I put it on top of the equation we want to calculate. Let's enter this, negative 4.89 bracket x minus 0.3, close the bracket, squared, plus 7.94. Let's graph this, and I'm going to go zoom in 6 just to set them in standard window. So zoom 6, standard window, and now we'll look at it, the graph again. And so we're looking to find this 0. In fact, we don't consider that anything on the left of the y-axis because that would imply a negative time. We can see that we start up, it goes up and comes down, and let's find our 0. So second and trace, number 2 is the 0. We're on the left side, press enter, move the cursor to the right side, press enter, and now it'll calculate, and it's 1.57 seconds. So Duncan will hit the ground, at 1.57 seconds. Hit not the ground, sorry. Let's go with the water. Hit the water at 1.57 seconds.